So for this final part, we're trying to figure out for the elastic energy, which accounts for 800 joules of the total energy, how much is this purple rubber band stretched? What is the length of the rubber band when it's completely stretched for this problem? So let's fill in the parts that we do know. And remember, command period gets rid of the exponent. I'm going to hit enter. So at position 4, the elastic energy is 800 joules. The spring constant is given to me, right? That's 50. So we're going to add 50 there. Times, what we don't know is obviously the stretch. That's what we're trying to figure out. Okay. Once we have that, we just do algebraically. So we're just going to figure it out algebraically. So firstly, what did we do? So we used the elastic energy equation and filled in the information we knew, which was the elastic energy and the spring constant. So when you have an equation like this, just like in math, in your algebra class, the first thing you need to do, what your whole goal here, I'm actually going to zoom in so you can see what I'm talking about. So your whole goal here is try to isolate the stretch, the variable that you're solving for. Since this is attached to an exponent, we know that eventually we're going to need to do a square root to get rid of that exponent, but let's not worry about it for this first step. Before we do that, we need to get rid of the variable from this 50. And to do that, you just do the opposite of what's happening here. Okay, so 50 times d squared, the opposite of multiplication is division. So you're going to divide 50 on both sides. So 800 divided by 50 is 16 equals d squared. I'm going to just flip these so I have d squared on one side equals, d squared equals, and let's not make that an exponent, 16. All I did was flip it, so I have the variable that I'm solving for on the left. So the next thing I need to do is get rid of the exponent. And the opposite of an exponent is a root. So since you have a squared here, the opposite of a squared exponent is a square root. That's where the word comes from. So here you have d equals the square root of 16. And you can find the symbol if you'd like. I'm just going to use SQRT because this is actually the coding language that you're going to need to use eventually for the app that we're going to create in class. Sorry. Okay, and then the square root of 16, you should know, is 4. And since what we're looking for is a distance, we know that our unit for distance is going to be meters. And that's your answer there. Okay, so what did we do again? We used the elastic energy equation and filled in the information we knew, which was the EG and K at, I'm going to say at position 4, because that's what we're solving for. And then we solved for the distance stretched algebraically. And that's it. So just a couple things to note, just to kind of review what we did. We started off with some information. We filled in the bar charts to make sure we knew where we were. At each position, we looked for the zeros. Then we calculated the gravitational energy. We used that energy and subtracted from the original 1,000 at each position to find the missing quantities. And remember that you won't be using this equation for this quiz. Please remember that your quiz is on Friday. So you have tonight and you have tomorrow to study. The next slide for you, it's going to be slide, I think, 18. This is another example. So you're going to do the exact same thing. I don't know why that's tiny. Yours shouldn't be like that. But you're going to do the exact same thing, fill out the bar charts, find the missing energy. I give you different numbers here to work with so you can practice. And then the next one, for this one, you actually have no help, right? None of it is done for you, so it's all blank. And then for the third one, same thing. You have to do it completely from scratch using different numbers. I apologize that, I don't know why it looks like that. Yours should not look like that. It should look like this. If you have any questions, email me or come see me tomorrow. Bye, guys. Sorry, one last note. For slide 18, the second slide, I want you to do this on your own, and then I want you to do slide 19 on your own. Tonight, which is Wednesday night, I will post a video that explains this slide. I won't explain slide 19 because that's just practice for yourself, but I will post a video for slide 18 that explains what you should get at each position, just so that you can check your work. Make sure you study.